Hi, I'm Andrew Steinacher, and I'm with Wolfram Alpha, and I'm going to be talking about food and nutrition in the Wolfram language, including a lot of the new ingredient substitutions and packaged food data that we have available. I'm going to be talking about food and nutrition. I put Brandon's name on here too. He's the other lead developer on this project, and let's get started. So first thing I want to do when we get in is I want to give you a brief overview of what we have available in the language. I intend to try and make it pretty brief because there's a lot of information there. I'll show you more information about that on a future slide. But I'm really trying to show off or show you some of the improvements that we have made to existing stuff, as well as a lot of the new things that we've hooked up to. As I had mentioned, I've done this talk or talks just like this in the past 2 years, and I've tried to compile as much of the information as I can into this one slide here. So please download the notebook. It's unpathable. There's lots of other information that I can't show in the amount of time that's here, but please feel free to download the notebook. It's unpathable, and all the information that you may need to know is here as well. So to give you a whirlwind intro to the food and nutrition information in the language, we have information on about 150,000 foods now, spread over about 150 nutrients. We can do things like make nutrition labels, for example, and we also have detailed information on like fatty acids, for example. So in order to keep track of a lot of this stuff, we have to have a system to classify and represent various kinds of foods. And so we have a growing set of over 10,000 attributes spread over nearly 50 categories. And so that allows us to handle a lot of different kinds of foods like raw foods and fruits and things like that, as well as packaged foods. And so here's just some of the examples of the categories and some examples of the specific attributes that we have. We also have a lot of physical information on over 1,000 food types that our interns and internal curation team have curated, including images, inside-outside colors, and approximate shapes as well as their dimensions. And some of the cool things you can do with that data, as I've shown before in previous talks, you can find, say, vegetables with white or cream interiors weighted by their iron content and make a nice image collage out of it that way, as an example. Some of the other things we support too is natural language processing. And so if you type in, say, red delicious apple, we know how to classify that using our implicit entity syntax, as you can see here. The neat thing about this too is it's also smarter about things like brand names. So for example, if you put in Big Mac, we know that it's a burger, and Pepsi, we know they make drinks. So that information is built in, so that way you can say food in the way that you would typically say, maybe in a web form or something, as I've shown before. And of course, we also support a food type interpreter as well, and it's sort of a fuzzier way to sort of think of things, how you can more broadly look at things rather than capturing all of the details in one shot. So that's sort of a brief overview of what we have available in the language. That's sort of the core functionality of it. Now we can start talking about some of the improved things, and one of the things that we've been improving over the past couple of years is adding more and more foods. So we've been adding about 50,000 foods every year, and so now we're looking at almost about 150,000 foods, which is getting to be pretty large and very nice and pretty comprehensive, I think. Going a little deeper into the improvements we've made, one of the big improvements that we made involving colors, we have these sets of curated colors, but one of the problems we ran into with these is that it's difficult to know which color is, say, the most common color. We knew that we had curated that apples, for example, were red, green, or yellow, but the problem is that when you go use it in an application, you may not know which color to use. For example, like this one down here, where I've made a word cloud where I've weighted them by vitamin A, but I also want them to be colored according to their most common outside color. It's really difficult unless you have this property, so you can just pull out one color rather than a list of them and attempt to guess which color it's supposed to be. So again, we also have this on the outside colors as well as the inside colors, for example. Another improvement we made involved barcodes. And I had shown in my first talk in 2015 that you can do lookups based on barcodes and set up a barcode scanner just by taking an image and using barcode recognize. We've improved this a little further so that you don't have to include a check digit. So here you can kind of see it here where I've left off the 1 at the end here, and so I've given it one less digit than it needs, but our stuff actually computes that check digit and puts it in there so you can hunt through those without much trouble. Another improvement we made with barcodes is supporting GTIN, which is the Global Trade Identification Number. And it's basically a superset of the typical UPCs that you see that are usually 12 digits long. GTINs can be 8, I think 11, 12, and 13 and 14 digits long. And so, for example, we can support it here with this one, which gives an 8-digit one, as well as you can use barcode image to create your own barcodes out of it as well. Another improvement we made was with a visualization property that we introduced called Compass Plot, which sort of gives a nice visual way to represent how much food, your nutrition intake, and how it relates to, say, limitations, basically, if it's like your daily values or other nutritional goals. We got a few complaints about how to read it and not really understand it. They didn't really understand what it was and how to read it. And so one way to fix that, as you can see, is we've supported zooming in and changing the scale. So for the same food, but just with different amounts, you can see that we've now zoomed in so the shape is still visible at basically every scale you can think of just about. But the scale changes, and we've introduced a legend to also see that too. And so you can kind of see in the old ones, which I've put up here, that when you get to really large limits, like in the tolerable upper intake level, it's very kind of tiny. It's, you know, a handful of pixels down there that you really have to squint and look at. With the new system, you don't have to, because the scales change appropriately so that you can see the overall shape of it. Another improvement that we made last year was that we introduced over 25,000 international foods from 20 countries or so. And so we've introduced that stuff. And to give you a brief review, these were tagged up with a Langual International Food Thesaurus, which has over 7,000 detailed terms for all sorts of things, and they're translated into several different languages, which is very convenient when working with foods that come from other countries and things like that. And so these foods were tagged up, as I mentioned, by compilers. They manually go through and curate which tags go with which foods and that sort of thing. And we support lookups with those using implicit entity syntax, as in this example that I showed last year, where you can find, say, cheeses by going through and picking out some Langual terms. Previously, up until now, that was really the only way you could go through these, was you'd have to know the thesaurus and know which terms you were looking for and create your query from there and search through them that way. But after some alignment effort, now you don't have to do that. Instead, we've gone through and set up the alignment so that you can just use our typical attributes that we have already, food types and those sorts of things, just to search through them. So here, for example, I'm using the fishes food type group to be able to grab all kinds of fish in the European data that we have available. Going a little further with the international route, one thing that is supported internationally in grocery stores and other things are price lookup codes, or PLU codes, as people typically recognize them. And they're the 4-digit codes that you see on produce and things like that, little stickers on apples and things like that that you may see in a grocery store. And there's a lot of information that goes with these. Because they need to be able to, grocery stores need to maintain prices and inventory and that sort of thing for, you know, maybe hundreds of varieties of foods, fruits and vegetables, for example. And so we have a lot of that information included and attached to these entities now, including the count size, which is what we use in the US to measure the size based on how many fit in a standard container, whereas in the rest of the world you may use a mass or a diameter, as you can see here. So going a little deeper with these PLU codes, I've mentioned before with barcode scanning things, you can write a little bit of Wolfram Language code to be able to do a similar thing with PLU codes, where I've just used barcode recognize here on a little bit of code to manipulate the string that comes back to pull out the PLU code that's needed, and then also sort of use the entity framework to be able to pick out how we would represent that using our implicit entity syntax. So you can see here that 4053 goes with lemons and 4131 goes with Fuji apples. Another new feature that we introduced was with pH information. So it's sometimes nice to know this information at the food type level. So we have, for food types, we have pHs, and you can sort through these things and search through them using implicit entity syntax. So here, for example, like you can find basic foods just by using greater than, or you can find acidic foods using less equal than, for example. And you can also use between to find maybe, say, sort of neutral foods in a particular range. Or you can also use take largest and take smallest to find the extreme values and those sorts of things. These values have been aggregated over more detailed information that comes from our data source, and so you can see sometimes there's some variation between different kinds, like here from different varieties of apples, they vary a little bit. It's also nice to see and group things on more of a food type group level, so you can sort of zoom out and see things in bigger clumps of foods that way. So that's kind of a nice use of number line plot to see that. Going a little further, one of the other big things we introduced last year was packaged food ingredients. And we had tens of thousands of foods. I don't remember exactly how many we had, but we have quite a few more now. And now we have about 100,000 packaged foods in our database now. And we have all kinds of information that you would find on a package, including marketing descriptions, as well as these warning labels and ingredient lists that you can see here. And a lot of these have very useful information, like, for example, allergens and things like that. And if you have a dietary restriction or an allergy or something, these lists are very handy to go through and find out what foods you can and can't eat. But the problem with these is that they come back to us as raw strings. And there's a lot of problems with that because they're not really computable or not very easily computable. A lot of times they come in as capital letters, and so they're not really all that friendly to look at because it looks like someone screaming at you, basically. And so it's not really nice looking. Also, there's a hierarchical structure to these things, and so they're a little difficult to work with if you want to actually find out what ingredients are made of, other ingredients, and those sorts of things. So if you want to find maybe the high-level ingredients, you'd have to do a lot of string processing to rip out parentheses and things like that to go dig through those. But most importantly, lookups are really difficult because you'd have to do some kind of string matching and that sort of thing, and that becomes very difficult very quickly. So the solution to that is that we've done it for you already and introduced our own ingredient entities. So here's just an example of some of the food ingredient entities you can see here. We have a list of a little less than 5,000, and we're growing in size as we go along. And so, for example, with the simple property call, you can just get back a list of these computable ingredient entities rather than this big string here. And one thing to note about these entities is that they come back in. We've tried to keep the order as close as possible to what's in the given in the actual string there, minus some duplicates and things like that, because the order is pretty important because the first listed ingredients are much more, there's much more of those ingredients than there are in subsequent ingredients. So the order is pretty important with those. And there are other properties that we have as well, which you'll see shortly. But the important thing is that you can use the implicit entity syntax to be able to search through these foods pretty easily. So for example, if you want to find foods that have a certain ingredient on them, you can search through them that way. And of course, you can use the contains family of functions to be able to find those that match a certain criteria. Maybe like this one, where you might be looking for ingredients that list both rice and beer. Or maybe use contains none to say find beans that don't have salt listed as an ingredient. Of course, as I mentioned before, if you're trying to do some of that string processing work to try and figure out which ingredients are made of what other ingredients, we've taken some of that into consideration already using this property which we call main ingredients, which basically removes the parentheses and takes out anything after a statement like contains less than 2% of. And so you can do queries on those, for example, here. And so that sort of gives a simplified list of ingredients to work with. Additionally, we also give access to the first listed ingredient, which I mentioned before is the one that's the most prevalent or predominant. And lastly, we also have a property for looking at ingredient counts, so that way you can search for foods that have less than a certain number or something like that too. And like I mentioned before on the other slide, with all the contains family of functions works on these as well. So you can dig through and search through foods that way. So that solves the lookup problem, but it's a little more difficult if you want to use it for if you have, say, an allergy or something like that. And so we've introduced entities for that as well to make it much easier to sort through. We've introduced these dietary restriction entities, and you can see a list of them here. And we have curated lists of food types and ingredients that you can avoid for all of these things, just given in these properties here, as you can see. The neat thing about this is that we give multiple lists of levels of confidence, basically, if you want to think of it that way. For example, we have compatible ones, which are certainly allowed, incompatible ones, which are definitely not allowed, and then sort of questionable lists, which are sort of gray areas where you may have to dig deeper and look into with all these things. And we have all this information as well down at the food level as well. So for example, you can use this to look for gluten-free foods that we have or foods that are certainly not gluten-free as well. Again, sometimes we get a lot of questions about, the differences between the dietary restrictions and things like that. So we've also introduced a description property that gives sort of a nice textual description of what these things are and why you may do them and that sort of thing. Another issue that people get confused on how these all relate. So we've also introduced an implied dietary restrictions property that allows you to say that, if a food is gluten-free, then it's also wheat-free. If a food is vegan, it's also vegetarian, and so on and so forth. Another new feature that we've introduced is with ingredient substitutions. We have a growing list of about 2,000 ingredient substitutions, and it's growing, and we're looking to improve it. So for example, here I've just put allspice as an example, where you can see with the implicit entity syntax we have here, you can replace it with ground cinnamon, ground cloves, and ground nutmeg. But this might be a little bit difficult to read, so I think I've got a little better solution for you here, where I've replaced them with images instead, sort of to integrate with the images that we have baked into the system. So you can kind of see what these things are. And I've also included it with mouse overs on them so you can see exactly what they are before. So right now, these are written in terms of explicit quantities, and I believe Eric has a talk later in the conference that covers physical quantities and things like that with Michael, and so we support all of these, and so you can convert these as you need. One of the features we do want to support is, giving these in terms of typical imperial units, like maybe teaspoons and tablespoons, but it's a work in progress at the moment. We're getting there. But we also support other units too, like for example, items. So you can see here that maybe an avocado leaf, if you have a recipe that calls for that, you may rather use 2 bay leaves instead to replace it, for example. Now these explicit quantities are nice and everything, but sometimes you don't know what you're working with, what exact numbers you're working with. So sometimes it's nicer to have things in terms of ratios. So by eliminating the quantities in the left-hand sides of these rules, we can sort of represent these on a more ratio level, so you can just multiply by a factor to get whatever you need. So for example here, on the ground allspice example now, we can see that 40% by volume, you can get these two, and only 6% by volume will give you that, so that way you can scale it to any quantity that you would like to have. Items are done in the same way, except the ratios are pretty clear, a 1-to-2 ratio and so on and so forth. Now to go another level deeper, you can see things on a more qualitative level, and so we can do that by looking at the food types that we have available to us. So you can see maybe you have a recipe that calls for acai berry. You might want to replace them with blueberries or cranberries or cherries, for example, or other things like that. And this also allows to do reverse lookups using implicit entity syntax, and that means that you can say, if I have this certain ingredient, what else can I use? What can be replaced by it? And so you can use that to find better replacements that way, and maybe a fancier recipe that calls for something more interesting that way. Lastly, I guess I'll go ahead and finish up by showing some of our future goals. Soon we're going to be updating the Wolfram Alpha scanner output, and as well as the API that goes with it. And so here I've given a brief screenshot to kind of show you some of the work that we're doing there. So that will be happening hopefully soon in the next couple weeks. And then lastly, some more things that we really want to do in the future here is cover more food nutrition for the rest of the world. Our first target, I think, on what we want to add next is probably Asian foods and that sort of thing. We also are wanting to cover more packaged foods and more data that's related to them, involving storage times and temperatures, as well as packaging dimensions and the materials that are used with them. We'd also like to align to ingredient entities, our ingredient entities to the ones that are in chemical data. I know Jason Biggs is giving a talk about that. In the future, we'd like to align to those entities as well. And another big project that we'd like to do is handle FDA nutrition labels with the different sizes and shapes and those sorts of things. And then, of course, this can all probably fit together into a really nice computational recipe system now that we have most of the pieces for these, including the nutrition and the actions and equipment that I've shown before, as well as the new ingredient substitutions that I've just shown here. And with that, I will open it for questions, I guess. Oh, yeah.
Could you comment more about this scanner that you mentioned in the previous slide?
You mean the Wolfram Alpha scanner?
Yes. Could it be installed
Well, so when I'm referring to the Wolfram Alpha scanner, I mean if you go to wolframalpha.com and you type in calories in a cheeseburger or something like that, that's the output that we're updating. Right now, it's not up to date with most of the things that I've shown in this talk, but it will be soon. So.
Scanner refers to a piece of the
Yes.
Wolfram architecture,
Yes.
the processing,
Right.
physical tests.
Right.
I was wondering if you plan to be able to scan, say, the food items and load it into.
Yeah. Yeah, it's very similar.
You scan in the barcode and say, oh, I had this and this and this. This was my breakfast, this was my lunch, and then what should I eat for dinner?
So you can already do that?
Yes. Oh, absolutely.
Okay.
Yeah, and in fact, it's very similar to this one here. Yeah. Yeah, it's actually very similar to this example here, where I'm using barcode recognize to read in the barcode that's written on the PLU codes. It's just a different barcode, but yes, we do support that. As far as in Wolfram Alpha, I think for now you may have to type in the numbers yourself and read it off the barcode, but we will support that sometime, hopefully soon. So. Yeah, I can build you something like that. It's a very simple query. You're right. It's not that difficult to do. So, yeah.
Propose dynamic barcode recognizing current image stop.
Yeah, that would be a good one. I haven't done that myself, but yes, that would be really handy. Yeah, yeah.
Or you can probably upload the image to Wolfram Alpha.
Yes.
Figure out its barcode.
Right. That's true. Yeah, yeah. Mhm. Oh, yeah. As far as tutorials go on this, I think your best bet is going to be, unfortunately at the moment, to download this notebook and take a look at some of the information I have here. Unfortunately, the entity framework is not super well documented in my experience. There is some documentation about entity and entity property, but I think it's in the works to have documentation on specific domains and those sorts of things. Oh, it's on Pathable. I can talk to you afterwards if you're interested, but it's just on the Pathable. Yes. Right. Yes, it's, yeah.
Classes that you're talking about
Yeah.
somehow are especially applicable to food and less so to others. But by and large,
Right.
it's just a big,
Yeah.
huge collection of stuff organized in a way that the entity framework. So if you understand how entities work, you can use the
Exactly.
I talked to everybody for a specialist.
Yeah, absolutely, yeah. I'd be more than happy to talk about it, yes. Yeah. Yes, exactly, yes.
One more thing, if
Yeah.
you wanted to, let's say, have an app on iPhone to scan things and figure it out, you have to have internet connection, correct? Because this whole database exists
Yeah.
in Illinois.
Right, exactly. So your best bet is to write an API or a form function in the cloud. I think is probably the best bet to do that, which I've done before. I can show you how to do that if you're interested. But yeah, I think you're right. The best way is to communicate over APIs and those sorts of things. Mhm. Yeah.
Are you ever going to run out of foods?
Hopefully not.
I don't see the curve tailing off yet.
Yeah, not yet. No, it's still pretty linear and going up. So.
They want to go to the recipes. That's where we actually want to go.
Right.
We need all the other pieces to we can go there.
Dan, go ahead.
Do you think you could use your kind of official position as a food data person to get your hands on some Szechuan sauce?
I don't know about that, but I'm not so sure about that, but maybe, yeah. Oh, yeah, go ahead.
Out of curiosity, how large is your team working on this?
Well, I think it's pretty much myself and Brandon are pretty much the main developers. I know Bjorn and Michael help a lot, as well as two of our interns are here now. A lot of the curation work is being done by them and others in... Yes, yes. Yeah, there are food science. Yes. Right. Yeah, exactly. Right.
They have a huge food department. They have
Yeah, yeah. And also our internal curation team as well helps out a lot. So although it's just Brandon and I as lead developers on it, so to speak, there's a lot of help that we get from interns and the curation team and everyone else. So.
That's mostly, if you see these projects, there are not many people involved in it, right? There's usually one or two people working in the company who produces the project, right? You see Keiko's probably it's mostly her, right? So people who are usually working what you do in the company. Not many people involved.
How come the group is working on food and they are so skinny?
That's a good question. Yeah. Oh, thanks.
They don't have to taste test the food.
Yeah, exactly. Yeah, that's a good point. Yeah, exactly. Yeah. I guess if there are no more questions, then I guess we'll stop here. Thanks.